Now, nucleic acid is divided into two. We have two types of nucleic acid. So the two types of nucleic acid are what and what? DNA and what? And RNA. So these are the two types of nucleic acids, DNA and RNA. Now, DNA, what's the full meaning of DNA? Deoxyribonucleic acid, right? While the full meaning of RNA is what? Ribonucleic acid. Now, just like this building is, for this building to stand, we lay blocks on each other, right? Lay blocks on each other. This nucleic acid is like this building, a macromolecule, a big building. And for it to stand, we also have blocks that we lay on each other to form this building, nucleic acid. Now, the building block of nucleic acid is what? Nucleotide. So if you are asked anywhere, what's the building block of nucleic acid, what will you say? Nucleotides. Nucleotides are the building blocks of nucleic acid. Now, another thing, the blocks we use to make this building stand, the blocks are composed of cement, right? Sand, water, and other thing. It means this building block, this nucleotide, this building block is made up of something, right? Now, this building block, nucleotide, is composed of three things, which are nitrogenous base, also pentose sugar, and phosphate group. So, how many components are found in nucleotides? 3, right? These 3 things must be found before you call it a nucleotide. So, if you have only 2, is this a nucleotide? Like if you have nitrogenous base and pentose sugar alone, will you still call this a nucleotide? No, right? Good. Now, if you have only nitrogenous base and pentose, it is no longer a nucleotide, but a what? A nucleoside. Why? Because you've kept the phosphate group aside. So nucleoside contains what and what? Only nitrogenous base and what? And pentose sugar. Good. Now let's look at the nitrogenous bases. Now the nitrogenous bases can be divided into 2. Nitrogenous bases are either purines or what? Pyrimidines. Nitrogenous bases are either purines or pyrimidines. Now, the difference between purine and pyrimidine is one is fused ring, 2 rings fused together, while one is a single ring. Now, among purine and pyrimidine, which one is a fused ring? Purine is a fused ring, while pyrimidine is what? A single ring. Now, this is how it looks like. If you have something like this, now if you notice, this is the structure of purine and this is the structure of pyrimidine. If you notice, you see that this one is a 6-membered ring and a 5-membered ring fused together, right? 1, 2, 3, 4, 5, 6. 6-membered ring. 1, 2, 3, 4, 5. 5-membered ring. So we are fusing a 6-membered ring and a 5-membered ring together to give us our purine. While pyrimidines, only a 6-membered ring, right? If you forget anything we've said so far, don't forget that the 2 types of nucleic acids are what and what? DNA and what? RNA. And we said the building block of nucleic acid is what? Nucleotides. And nucleotides are composed of nitrogenous base, pentose sugar, and what? Phosphate. And if you keep the phosphate group aside, what you now have is what? A nucleoside. A nucleoside. So that's why some of you used to say, you are the phosphate in my nucleotide. Without you, I'm just a nucleoside. Because it is phosphate that makes a nucleotide a nucleotide. If phosphate is not there, it's not a nucleotide. Now, In this purine, we've known that purines are fused rings, right? Two rings fused together, and pyrimidines are single rings. The next thing we need to note, examples of purine, we have the main ones are adenine and guanine. While examples of pyrimidines, the main ones are cytosine, uracil, and thymine. Pay attention here. So if you are asked to give an examples of purines, what do you say? Adenine and guanine. Or examples of pyrimidines are cytosine, uracil, and thymine. So to remember this, you can always say pure as gold. Pure as gold. So purine as gold is the as is adenine, gold is guanine. So pure as gold. Then pyrimidines, CUT, cut. CUT, cut. CUT, cut. So you can always use that to remember the pyrimidines. Alright. But now out of these three bases we have as pyrimidines, uracil is only found in RNA, while thymine is only found where? In DNA. So can you find, on a normal day, can you find thymine in RNA? No, right? Because thymine is only found in what? DNA. While uracil is only found in RNA. What of cytosine? Can be found in both, right? Can be found in RNA, can be found in DNA. These two can be found in RNA, can be found in DNA also. So these are the bases, nitrogenous bases. As we go on, we'll learn how to draw all of them. They are very, very simple to draw. So we'll learn how to draw them in this class. Now the next thing, we've looked at nitrogenous bases. The next component of the nucleotide is what? Pentose sugar, right? Now the pentose sugar can either be ribose or deoxyribose. So those are the two possible pentose we can have. Pentose is 5 carbon sugar, is it not? Now in biochemistry, any word ending with os, no, it's what? Sugar. Any word ending with os is sugar. So pentose, pen, 5, sugar. So 5 carbon sugars, sugars with 5 carbons. Good. So the pentose sugars can either be ribose or what? Deoxyribose. Among ribose and deoxyribose, which one is found in RNA? Ribose, right? So ribose is found in RNA, while deoxyribose is found in DNA. That is where the name of this nucleic acid came from. This name, ribonucleic acid, right? This is ribonucleic acid, meaning nucleic acid containing what? Ribose sugar. Are you following? Nucleic acid containing ribose sugar. This one is deoxyribonucleic acid, right? Meaning nucleic acid containing what? Deoxyribose sugar. Do you understand? So we've seen, from what I've said so far, we've seen two differences between RNA and DNA. RNA contains ribose, right? While DNA contains what? Deoxyribose, is it not? Good. Then another thing we've seen is RNA, uracil is found in RNA, while thymine is found in DNA. So